Our final speaker for this session is Ivan Katkov, fast interactive web-based data visualizer of panoramic spectroscopic surveys. Take it away.
Hi everyone, I'm postdoc at New York University Abu Dhabi, as well as adjunct researcher at Moscow State University. First of all, thanks organizers to having me here, and I'd like to present another project from our extragalactic team, VOxAstro team. This is a tool for visualization of current panoramic spectroscopic surveys. So the motivation behind the project is that optical spectroscopy optical spectroscopy is very important for galaxy physics because it provides opportunity to get a lot of information about the galaxies. You can extract kinematics of stars, velocities, velocity dispersions, INS-gas kinematics, line ratios give you understanding of the abundance of the different elements, stellar population properties, and all bunch of these parameters. Considering a whole bunch of these parameters for large samples of galaxies covering different range of the galaxy mass and different environmental parameters provides a very unique basement for study galaxy evolution. And considering spatially resolved spectroscopy, it's more important because IFU spectroscopy provides much more information compared to aperture spectroscopy. That's why recently have been performed and released many IFU surveys, which are very useful for studies of galaxies. In our group, one of the main direction of research is galaxy studies, and I personally interested in different aspects like searching for and study galaxies with kinematically decoupled structures, stellar contour rotation, and galaxies with large-scale outflows. And all this project would be benefited from the tool where you can check is your galaxy or some sample of galaxies has appropriate IFU data, what's the quality of this data, and what's the result of the data products provided by different surveys or our own data products. And this is where IFU visualizer comes in. So this visualizer have roughly two parts, search and table view and detailed page view. Let's start from the first one. The heart of the search and table view is the input field where you can write your search query. And thanks to Django custom query package, you can able to write queries similar to where SQL clause. You can write relatively complicated queries which consist of different conditions using different comparison operators, non-strict comparison, between, in, combined in. We also support in simple mathematical operations between columns, and all these statements can be joined using logical operators and or. Also, this provides a possibility to have a current search queries and using CSAM CDS server service to name resolution to the current search. So, and let's go through the couple of examples. For instance, this query gives you a list of the spectral cubes taken from the SAMI survey for galaxies with declination less than 10 degrees. In operator is very useful if you have some pre-selected set of galaxies. For non-strict comparison, very useful if you, let's say, you forget your favorite name of your favorite galaxy, but you remember that the name contains 6,4. Using this operator, you will find a bunch of the galaxies. Likely one of them would be your favorite galaxy. If you write down just in GC 4173, this query will be resolved as a kern search with default radius, and you will get spectral cubes for this particular galaxy. And another more complicated case, it helps you to pre-select galaxies located in the comma cluster, plus with condition on the GR color between 0.1 and 0.5. So it helps to select blue galaxies in comma clusters. If you keen listeners can notice that in some of my screenshots, the list of columns in the table changed, and this is thanks to the column customization. If you click on the table settings, you will see total list of the currently available tables available in the service. Expanding each table, you will see a list of the columns, and clicking on different columns, you can customize which columns will be presented in fully interactive table, which is sortable, scrollable, which makes some sense. Talking about cube page, right now it has limiting functionality because our IFU visualizer is still under development. But here you use on the top few tabs where parameters from all available related tables to this particular spectral cubes are available. Then Aladdin Light with a set of buttons where you can quickly change imaging surveys, and clicking and on the Aladdin, it's also in the gray line, you see field of view of the spectral cubes, and clicking on different point of the galaxy, you will almost immediately retrieve galaxy from the retrieve spectra from the spectral cube, which will be fully interactive thanks for Plotly.js library. This is how our cube page will looks like a little bit later. This is based. I'm showing you a screenshot from our first prototype of the IFU visualizer, which is called MaNGA visualizer, and it provides access for MaNGA data only, and you can see a lot of two-dimensional maps recovered from the spectral cubes, as well as spectra with best fit model, residuals, everything can be zoom in, zoom out, and also each panel and spectra has a setting button where you can change scaling adjustment, a type of color scheme, and so on and so on. Currently, in our visualizer, we have only 4 spectroscopic surveys: MaNGA, SAMI, Califa, Atlas 3D, which contain roughly 10,000 spectral cubes, and later this number will be increased thanks to next forthcoming data release of the SDSS data DR17. And also we have some plans to add some Muse cubes, which are in the field of our interest from the scientific point of view. And let's go now through technological technologies which we used in this visualizer. First of all, our web application, it's a single-page application. It means that upon initial request of this server, return basic HTML and JavaScript bundle, and then everything what you see on the screen controlled by JavaScript, making your user experience very smooth, because you no need to re-render HTML, and data comes from the server using asynchronous request directly to IP backend server. Their server decide based on business logic should it retrieve data from directly database or from the spectral cubes, then serializing this data and return to the client. These are the list of all libraries, technologies we used in IFU visualizer. And speaking about backend, we based on the PostgreSQL database because of we would like to have current search queries which are supported by great extensions Q3 CPG Sphere, and also would like to have integration with Vue services, which is one of our points for further development. And Django framework, Python-based, very popular, extremely well documented, which has a lot of batteries, which helps in some cases. But at the beginning, then we designing our IP, we decided to try to use a very popular nowadays GraphQL architecture for developing IP based on Django GraphQL library. It's nice because GraphQL provides only one endpoint, and killer feature is that you get exactly that result that you requested, minimizing overheads for serialization and transferring data. But it was surprisingly that simple Django REST framework provides 2-3 times faster query processing. And since Django has a very nice battery called Flex Fields, which mimicking a killer feature of GraphQL, that's why we decided to continue with Django REST framework, at least at the moment. And let's see, maybe later use cases might be better developed with GraphQL. We choose between React and Vue framework, but thanks to amazing Quasar framework, which contains a lot of components, data tables, buttons, panels, spinners, and so on, which makes designing of the interface like a charm, we of course decided to use Vue for this project. And we are developing our custom components. We are trying to focus, we are trying to make our custom components as clean as possible and separate logic to separate part of the retrieving data and post-processing of data in the state management of our application, and which makes our components clean and more representative. Currently, the status of the IFU visualizer is that we have very early stage of the development. Sometimes development like super intensive, I would say like violent, and some pieces of this part can be changed a little bit. And here is our next steps. First of all, we wanted to improve main cube page where details of the spectral cube can be considered, and this is a main place for visualization. Then we plan to provide additional data products, something similar that we are doing for RC set catalog. Of course, we have to add some Vue compliant services. And I can't anymore separate you from the great time in Cape Town, and I would like to stop here and leave you these takeaway messages. Thank you so much.
Thank you very much for this very interesting talk. The only question we have currently is by Oleg. Maybe you can just ask it live.
Yeah, thanks very much for that. I was wondering, when I was looking at your web-based image visualization, did you happen to be in the Carta tutorial yesterday? And have you considered using something like Carta, or the other tool available is called JS9 for like browser-based FITS file viewing? Yeah. Because I think there's a lot of potential for integration there for this kind of thing.
Talking about Carta can be integrated, yes. Carta has some, well, what I saw yesterday, Carta is an amazing tool, but as far as I understand, that the people who are developing Carta, they mostly focus on radio data. That's why, for instance, for my site, like a person who are doing research based on the optical spectroscopy, it's important, most important to see optical spectra, spectral profiler, which is, for Carta, you need to click many, many times to show this profiler. So this is my personal use case. And another important thing that our tool will provide opportunity to visualize our data products, which can be a little bit more complicated, like spectral cubes plus different extensions containing, let's say, non-parametrical error recovery, line of sight velocity distribution, or something more. So doing our own instrument gives us opportunity to make it as flexible as possible for our scientific goals.
Okay, thanks very much.
Thank you very much. Do we have any other questions in the room, maybe? And it doesn't seem like we are getting any more questions online either. So thank you very much again.
Yeah, thank you so much. Thank you.